Question B, it says the car accelerates along a level road from 80 kilometers per hour to 110 kilometers per hour in 6 seconds to pass another car. So here's my car on a flat surface. I have some applied force in order to go. There's the resisting force, Fr, still 700 newtons from before. Before we start, we actually need to find out the distance, because work is force times distance. So say V final is equal to V initial plus acceleration times time. So you see acceleration is equal to V final minus V initial over time. So we need to convert 90 kilometers per hour and 110 kilometers per hour to meters per second. So we divide those each by 3.6. You get acceleration is 30.6 meters per second minus 25 meters per second, all over 6 seconds. A is equal to 0.93 meters per second squared. Now I say d is equal to v0t plus 1/2 at squared. Plug it on them and get d is equal to 167 meters. So there's our distance traveled. A little bit of kinematics. Always throwing it in every once in a while. So it says calculate the power. So what's our F net? F net is equal to applied force minus our all those resisting forces. So you applied force is equal to F net plus Fr. So you have 1400 kilograms as accelerating at 0.93 meters per second squared. We're adding 700 newtons to that. And we get a value of 2,000 newtons. So we need to exert a force of 2,000 newtons in order to achieve that acceleration. So power is equal to work over time. Work is force times distance over time. We know our distance. We know our time. Power comes out to be 5.6 times 10 to the 4 watts. Or if I want horsepower, that comes out to be 75 horsepower.